In this section, we're going to discuss word problems that have to do with wind and water current. So what we need to realize is that if you're sitting on a boat in the water, this is obviously a boat, and the current is going this way, and you are trying to travel this way, with your motor or whatnot, your speed is actually going to be faster than the speed of the boat. Just pushing itself because the current will also push you. Now, if you wanted to go the opposite direction, well, your speed is actually going to be slower because the current is trying to push away from you. In these problems, what our variables are the speed of the boat and the speed of the current of the water. So we need to set up our equations using those two variables. First thing we're going to deal with is figuring out the rate that you travel downstream. If you were traveling downstream, that's the example with going with the current. Your speed is going to be faster. You're going to have the speed of the boat, which we're going to call R, plus the current of the water. And so your rate will be faster because it's the addition of these two things. If you're going upstream, you're going against the current. That means the current is pushing one way and your boat is trying to go the other way. The rate that you travel upstream will be the difference between those two rates. The same thing applies if you are in an airplane flying. So here's my airplane down here. It's obviously an airplane. And let's say the airplane is flying in this direction. Well, if the wind is blowing in this direction, you're going with the wind and your speed will actually be faster. So we're calling R the speed of the plane and W the speed of the wind. Well, R plus W would be your actual speed then. If you're traveling against the wind, that is, if the wind is blowing in this direction, it's going to take away from your rate. So you're going to have this be the speed of the plane minus the speed of the wind. Very similar to the other setup, we're just using W instead of C because we're talking about wind instead of water current. In a canoe race, a team paddles downstream 480 meters in 60 seconds. The same team makes the trip upstream in 80 seconds. Find the team's rate in still water and the rate of the current. So what we're trying to figure out, the team's rate in still water is the R that we were dealing with in the last clip, and the rate of the current is the C that we were dealing with in that clip. We're going to use a chart to figure this out, and the columns of the chart are going to be our rate times distance, that familiar formula to us, because we know that rate times time equals distance. The columns or the rows here are going to be when we go downstream and when we go upstream. Rate is what we're asking for you to solve. So rate must be a variable. Now our rate going downstream, we're going with the current, so it's going to be R plus C. We have two variables in here. It'll be okay. Upstream, R minus C. Now the rest we can fill out using the information given in the problem. The time it takes us to go downstream is 60 seconds, and the time it takes to go upstream is 80. The distance travel is the same for both, because going downstream and upstream was this trip. With my table complete, I can now set up my system of equations. What I know is that rate times time equals distance. So I have rate times my time equals distance. I can make this equation much simpler to solve by dividing both sides by 60. Then I will get R plus C equals 8. I can do the same thing with the second row and say, well, R minus C times 80 is 480. Divide both sides by 80 and I will get R minus C equals 6. I now have two equations, here and here, as a system that I can solve and figure out what R and C are. Let's rewrite those. r plus c equals 8, r minus c equals 6. This setup is perfect for the addition method of solving a system of equations. If I add the two equations together, I'm going to get that 2r equals 14. So r must be 7. If r is 7, plug it back into one of these, I'm going to figure out that c must be 1. So the rate of the canoe in still water is 7 meters per second, and the rate of the water current is 1 meter per second. It takes an airplane an hour and 30 minutes to fly 600 kilometers against the wind. The return trip only takes 1 hour. Find the total flying time for the round trip if there was no wind. Well, I can fill out my chart. Rate times time equals distance. And here I'm going to be, we'll say, with the wind and against the wind. My rate with the wind, I'm going to call the r plus w, because the wind pushes us and we go faster, so we add the two speeds together. And against the wind will be r minus w. Time with the wind is during the return trip, and that only takes 1 hour. So with the wind, it only takes me 1 hour to go the 600 kilometers. Against the wind is the hour and 30 minutes. I'm going to make that 1.5 hours. And that again will be 600. So the two equations that I can set up to solve, r plus w times 1 equals 600, and r minus w times 1.5 equals 600. If I divide both of these by this number, the first equation, just r plus w equals 600, and the second equation, r minus w equals 600 divided by 1.5 is, I believe, 400. In this problem, we have a plane flying with the wind and against the wind. So again, I'm going to use r plus w for rate with the wind and r minus w for rate against the wind. The time it takes to fly with the wind is 1.5 hours and against the wind is 2. The total distance that they're flying is 108. So my two equations, r plus w times 1.5 and r minus w times 2 equals the distance. Divide both equations to make them simpler. In the first equation, I'm going to divide by 1.5 and get 720. And in the second equation, I'm going to divide by 2 and get 540. Once I get to this step, you can solve and finish the problem to find r and w.